Hey everyone, welcome back to CloudBridge Tech Labs. I am absolutely pumped you're here today because, well, we've hit a really huge milestone. This is our final Phase 1 explainer, and we are definitely going out with a bang by mastering one of the most critical skills you can possibly possess in this field, DevOps troubleshooting. We're going to take all the foundational knowledge you've built up over this phase and forge it into a razor-sharp diagnostic toolkit. Let's get right into it.
Here's our roadmap for today's explainer. First, the app is down panic. Then, the real DevOps mindset, followed by our core 8-layer troubleshooting flow, and finally, your Phase 1 final project.
All right, Section 1. The app is down panic, handling the dreaded user report. Okay, let's set the scene. We've all been there, right? That high-stress scenario every engineer eventually faces. You get that message, my application is down. Instantly, your stomach drops. The panic just kind of sets in. But look, we need to reframe this right now. It's not a disaster, it's a mystery. And you're the tech detective called in to urgently crack the case. Honestly, what you do in the next 5 minutes is exactly what defines your skill level in this industry.
Moving into Section 2, the real DevOps mindset. It is time to ditch the amateur habits.
So, this brings us to how a true pro reacts versus someone who's, well, just guessing. Look at this stark contrast. On the left, we've got the classic amateur move, just randomly restarting the server, the good old reboot and pray technique. Sure, maybe the app comes back online, but you have zero clue why it crashed, meaning it's absolutely going to happen again. On the right, that's the real DevOps mindset. You troubleshoot layer by layer. True engineering needs layered systematic logic. We don't guess, we verify.
Section 3, the 8-layer troubleshooting flow, looking at the networking debug diagram.
So how exactly do we do that verifying? Let's map out our definitive step-by-step strategy. This right here is the 8-layer networking debug flow. I seriously want you to memorize this structure. It goes DNS, network, firewall, port, application, logs, SSL, and finally load balancer. Following this exact order is how you eliminate variables systematically instead of just running in circles. And honestly, this isn't just theory. This exact flow is a daily standard used everywhere from AWS to Kubernetes across complex production environments all over the world.
The absolutely crucial point here is starting at the very top of our flow. We aren't logging into a server yet, no way. We start from the outside acting just like a user would. We have to ask, is the domain actually resolving properly? And if it is it even pointing to the correct IP address?
We verify this right at step 1 by simply checking the DNS. You just use nslookup myapp.com. If that fails, well, the problem isn't your server at all. It's your DNS records. Boom, you've just saved yourself hours of useless server debugging, literally just by checking the front door first.
Now, if the DNS is totally fine and pointing to the right place, we step down a layer. We need to ask, is the server itself actually reachable on the network?
That brings us to Step 2, checking server reachability. Your go-to tech detective tools here are basic network connectivity commands. You just ping the server's IP to see if it's alive, or you can telnet into the IP on port 80 to see if it accepts a basic connection. If that ping fails, you're likely looking at a routing or broader network issue.
Okay, but what if the server is reachable? Well, we keep the investigation moving rapidly inward. Now we're questioning the health of the actual web service running on that machine. Is the application running, or has the whole thing completely crashed?
And here's where Step 3 comes in. We run systemctl status nginx to check up on the service. This tells you instantly if your nginx web server, or whatever service you happen to be running, is actively healthy, stopped, or if it failed and crashed hard. Assuming the service says it's healthy and running, we hit Steps 4 and 5. We have to verify the application is actually listening on the correct port. Running SSTULNP will confirm this for you. But hey, even if it's listening, traffic still might not be getting through. Enter Step 5, the firewall. You've got to check if an AWS security group or your local IP tables rules are actively blocking that port from the outside world.
Next up, we dive way deeper into the application secrets with Steps 6 and 7. If everything network-wise is wide open, but the app still isn't serving pages, you check the logs. Using journalctl/u ngx or just tailing the error log will literally spell out what the application is complaining about. Oh, and don't skip Step 7, SSL. Is the browser throwing a big, scary warning? You've got to verify if the SSL certificate is expired, or maybe someone just attached the wrong cert entirely. Finally, we wrap up our flow with Step 8, checking the load balancer. In modern setups, let's face it, users almost never hit your server directly, they hit a load balancer. So you need to verify if the load balancer's health checks are failing or if the backend servers are secretly unreachable from the load balancer's perspective.
All right, Section 4, your Phase 1 final project. This is it, the ultimate trial.
Now that we're totally armed with this incredible layered framework, it's time to unveil what it takes to officially graduate to Phase 2 of CloudBridge Tech Labs. For the Networking Foundation project, you're going to build an entire environment completely from scratch. I want you to spin up an Nginx server, configure a real domain name, implement HTTPS, set up a reverse proxy, and lock down secure SSH access. And yeah, you're building this entirely yourself, absolutely no shortcuts here.
But listen, building it? That's really only half the battle. Once it's running perfectly, you're going to face simulated outages. We're going to throw some intentional breaks at you, a DNS failure, a randomly blocked port, an expired SSL cert, and a stopped service. Your mission is to actively apply our 8-layer tech detective flow to hunt down and fix every single one of those issues.
I really want to highlight why this matters so much. Passing this project isn't just, busy work. It's basically the key that unlocks the rest of your career. Mastering this troubleshooting foundation makes advanced Phase 2 concepts like Docker networking, Kubernetes services, AWS virtual private clouds just so much easier to grasp. Because if you understand the layers here, you're going to understand them anywhere.
So, I'll leave you with this one question. Are you ready to stop guessing, ditch that reboot and pray habit, and actually start debugging like a true pro? I know you are for sure. Conquer this final project, prove your mastery over these layers, and I'll see you in Phase 2. Make sure you like this explainer and subscribe to CloudBridge Tech Labs so you don't miss our upcoming deep dives into Docker and Kubernetes. Happy troubleshooting, everyone!